Hello. Am I audible? सुनाई दे रहा है सब? कुमार, आकाश,
गुड आफ्टरनून।
गुड आफ्टरनून। सुनाई दे रहा है?
यस सर।
अच्छा, सो 2 मिनट थोड़ा वेट कर लेते हैं, सबको ज्वाइन करने दें। 11 आदमी ज्वाइन किया है।
ठीक है सर।
So let us start the class. Today we are going to start with the rest of the portion of Zener diode, that is as a Zener diode as a voltage regulator. We will discuss about the voltage regulator circuit and all the things. Then we will tell our Zener diode specifications. Okay. Next we will talk about applications. We have already discussed about Zener diode. In that applications we will talk something later about, and we will do some numericals problems. So to your class we will try to complete the Zener diode totally, and next we will go to the special diodes like tunnel diode and etc. So without further delay, we will start our class. So very good morning to everybody, and actually it is afternoon, so very good afternoon to everybody. And we will start today's our class on Zener diode, the rest of the Zener diode. So we will start with the applications of Zener diode. Last day we told different applications of Zener diode, and today we will start about the applications of the Zener diode. So today is today is 17/1/2022. So starting with the topic, Zener diode as a voltage regulator. Voltage regulator is a circuit whose function is to maintain a constant output DC voltage in spite of the AC input voltage fluctuation or change in the load resistance value. So that is voltage regulator. Voltage regulator is a circuit whose function is to maintain a constant output DC voltage in spite of the AC input voltage fluctuations or change in load resistance values. So a Zener diode regulator, we will first draw the circuit diagram of a Zener diode shunt regulator. So this is the Zener diode. This is plus, this is minus. This is supply voltage. This is the current represented by RS. RS is the shunt resistance. This is the Zener diode. This is a two terminal. Here the current is flowing to the diode, that is IZ. This is the generated voltage, that is VZ. Load resistance is, the load current is IL. This is the RL, load resistance. And this is the voltage drop across the load resistance, which is denoted by VL. This is nothing but a regulated voltage. This is the circuit diagram of a generator as a voltage regulator or shunt regulator. This is called shunt regulator because the Zener diode is connected in parallel or shunt with the load. That's why it is called shunt regulator. We can see the Zener diode is connected parallel with the load. That's why it is called shunt or uh, load resistance. Means Zener diode shunt regulator. The resistance RS is connected to the limit current in the circuit. The output or regulated voltage is often across the load resistance RL. For the operation of the circuit, the input voltage Vs should be greater than the Zener diode voltage Vz. Only then Zener diode operation in big ground region. So you must always remember that Vs must be greater than Vz. Then we will get the Zener diode operates in the breakdown region. So if I do the calculations, So if I write the calculations, the input current is calculated by the input current is calculated by Vs equals to Is into Rs plus Vz. Or we can write Is equals to Vs minus Vz by Rs. Here we can write Vs is the input DC unregulated voltage, and Vz is the voltage across Zener diode. Okay. The ideal Zener diode may be assumed as a constant voltage source of voltage Vz. But in case of practical Zener diode, Zener resistance is taken into account. Due to the Zener resistance, there is a voltage drop across it. And what is the voltage drop? It is Iz into Rz. This is the voltage drop. Voltage drop across the Zener resistance. Okay. The voltage across the terminals of Zener diode, which is also equal to the load voltage, may be given as VL equals to Vz plus Iz into Rz. But the Zener resistance may be depleted, but the Zener resistance may be neglected. Therefore, the load voltage is VL equals to Vz. The current through the load resistance can be written as current to the load resistance is IL equals to VL by RL. So according to KCL, the input current is given by IS equals to IZ plus IL, or that can be written as IZ equals to IS minus IL. So this is the input current. So no problem with this. Anybody, any question? Understand everybody?
Yes, sir.
Okay. So we are going to do the next part, that is the working principle, working of a Zener diode shunt regulator. So working of Zener diode shunt regulator. So let us draw the diagram of it, circuit diagram. You can see this. So now we are giving a variable voltage, Vs. This is variable. This is Rs. This is Iz. This is the current flowing IS. This is the load resistance coming down, IL. Okay, this is fixed value load resistance. This is fixed, and this is the voltage drop. That is VL. This is positive. This is negative. This is regulated voltage. Another diagram is for okay, no problem. So now we will do the triode. This is the resistance. And this is the voltage. This is VL. This is plus. This is minus. This is regulated voltage. Okay. This is the load resistance IL. This is the variable resistance RL. This is the current IZ. This is resistance RS. And this is the current flowing IS. This is Vs. Now this is fixed. So there are two circuit diagram for what for to describe the working of a generator in sun resistance. One is load resistance is varied. Load resistance varied, and another is input voltage is varied. Input voltage is varied. Okay, so as you see here, there are two cases. So let us start with the case one. That is regulation when input voltage is varied. That is regulation when input voltage is varied. What does it happen? In this case, the load resistance RL is kept fixed and the input voltage Vs is varied. When the increases, the input current Is is also increased. So I can write Is equals to Iz plus IL. This increased current Is increases the current through the generator without affecting the load current IL. Due to the increase in the input current Is, the voltage drop across the series resistance Rs also increases, and hence keeping the load voltage VL as constant. Now, when the input voltage decreases, the input current is also decreases. Due to this, the current through Zener diode also decreases. Also, the voltage drop and scare, sorry, also the voltage drop across the series resistance is also reduced. Hence, the voltage, load voltage VL and load current IL will remain constant. So, understand the first case?
इसे बताइए ना सर।
पहले क्या हो रहा है, पहले हम लोग लोड रेजिस्टेंस आरएल को कांस्टेंट रख रहे हैं, उसको फिक्स्ड रख रहे हैं, और इनपुट में जो वोल्टेज है वीएस, ये वाला हमारा वैरी कर रहा है, ये वाला मेरा वैरी कर रहा है और ये वाला मेरा फिक्स रह रहा है। ठीक है, तो जब भी हमारा इनपुट वोल्टेज इंक्रीज करेगा, द इनपुट करंट ये वाला ये भी इंक्रीज करेगा। सो अगर इनपुट वोल्टेज इनपुट वोल्टेज अगर हम लोग ज्यादा बढ़ाएंगे तो इनपुट करंट भी बढ़ जाएगा, क्योंकि मेरा जो कंडीशन आता है वो है आई एस इजल टू आई जेड वाई प्लस आई। तब with increased current IS increases the current through Zener diode without affecting the load current I1. ओके, तो अगर हम लोग IS इंक्रीज करेंगे तो करंट थ्रू द जेनर डायोड विदाउट अफेक्टिंग द लोड करंट IL वो भी इंक्रीज हो जाएगा, तो ये IL भी इंक्रीज हो जाएगा। ड्यू टू द इंक्रीज इन द इनपुट करंट IS में इंक्रीज होने की वजह से what happened, the voltage drop across the series resistance RS, वो जो सीरीज में जो रेजिस्टेंस है RS, ये वाला रेजिस्टेंस, उसका जो अगेंस्ट में जो वोल्टेज ड्रॉप होगा वो भी इंक्रीज करेगा। तो ये अगर इंक्रीज करता है तो हेंस कीपिंग द लोड वोल्टेज VLS कांस्टेंट, तो जो लोड वोल्टेज है ये वाला ये कांस्टेंट रखेगा। अगर इसको भी चेंज करेंगे तो और भी चेंज हो जाएगा, तो इसको कांस्टेंट रखने में वो सब चेंज हो जाएगा। अब जब इनपुट वोल्टेज कम हो रहा है, घट रहा है, तब इनपुट करंट भी घट रहा है, तो इनपुट वोल्टेज घट गया है, इनपुट करंट भी घट गया। अंडरस्टैंड? इसके वजह से द करंट थ्रू द जेनर डायोड आल्सो डिक्रीज। अगर ये होगा तो हम लोग का जेनर डायोड के अक्रॉस में जो करंट है वो भी डिक्रीज हो जाएगा, और अगर डिक्रीज हो जाएगा तो द करंट टू द जेनर डायोड वो भी कम हो जाएगा। अगर जेनर डायोड की अक्रॉस जो वोल्टेज ड्रॉप है वो सीरीज रेजिस्टेंस वो भी ड्रॉप हो जाएगा। तो क्या होगा, लोड वोल्टेज VL और लोड करंट IL वो दोनों कांस्टेंट रहेगा। दैट मीन्स ये जो VL है ये वाला और जो लोड करंट है ये वाला, ये दोनों कांस्टेंट वैल्यू रहेगा। बाद बाकी सब कमेगा या घटेगा, बढ़ेगा या घटेगा। अंडरस्टैंड? अब समझ में आया क्या हुआ? हेलो, हेलो।
ये सर समझ में आ गया सर।
ओके ओके। अब केस 2 के बारे में जो हम लोग बोल रहे हैं, केस 2, वो केस 2 की है रेगुलेशन तो ये हमारा सेकंड क्लास है, रेगुलेशन व्हेन लोड रेजिस्टेंस इज वेरिड। क्या होता है मतलब सेकंड केस। तो इन दिस केस द इनपुट वोल्टेज Vs इज कीप फिक्स्ड एंड द लोड रेजिस्टेंस ये हमारा फिक्स नहीं रहेगा और जो लोड रेजिस्टेंस ये हमारा वेरिएबल होगा। तो जब लोड रेजिस्टेंस कम होता है द लोड करंट बढ़ जाता है, ठीक है, तो ये बढ़ जाएगा और ये घट जाएगा। लोड रेजिस्टेंस के घटाने से लोड करंट का वैल्यू बढ़ेगा। ये क्या करता है, दिस कॉजेस द करंट ऑफ जेनर टू डिक्रीज। तो जेनर में जो करंट था ये वाला घट जाएगा। कोई प्रॉब्लम? जेनर करंट डिक्रीज तक ओके। Due to this, the input current and the voltage drop across the series resistance remains constant. Therefore, the load voltage VL equals to constant. Now, when the load resistance RL increase, the load current decrease. Due to this, the Zener current increase. This again keeps the value of the input current and voltage drop across the resistance as a constant. Therefore, the load voltage remains constant. Okay. So VL अगर कांस्टेंट हो जाता है द लोड वोल्टेज सबसे कांस्टेंट है। तो ये मेरा केस 2 है। अंडरस्टैंड केस 1 एंड केस 2? तो ये है मेरा शंट रेगुलेटर हिसाब से जो जेनर डायोड काम करता है उसका विवरण। अब जेनर डायोड का स्पेसिफिकेशन, जेनर डायोड का स्पेसिफिकेशन। So, Zener diode specification. तो जेनर डायोड स्पेसिफिकेशन में पहले जो पॉइंट आता है वो है हमारा जेनर वोल्टेज। The manufacturer specifies the value of breakdown voltage, which is known as Zener voltage, Vz, at some value of the test current, Izt. This is the linear portion of the reverse characteristics and corresponds to approximately 1/4 of the maximum power dissipation compatibility with the diode. Values of Vz are available at various values from 2.4 to 200 volt. So it is means from 2.4 to 200 it can be anything value, which occurs between 5 to 10 20%, 5 and 20% depending upon the cost. So that is general voltage. Number 2 point is power distribution. तो पावर डिसिपेशन के बारे में बात करते हैं। Power distribution in the diode is the product of Vz and reverse current Iz, with maximum power rating ranging from 160 milliwatt to 50 watt. So power distribution product of what? Product of Vz and Iz. This is the reverse saturation current or reverse current. Okay. And the power ratings ranging from 150 milliwatt to 50 watt. Okay. This is 50 watt. I think okay, everybody. Next is our what? Breakover current. Breakdown current. So because there is some curvature of the reverse characteristics at low values of Iz, there may be specified some value of current I of Zk in the neighborhood of the breakover V, where the voltage across the diode starts to differ greatly from Vz. That is called breakover current. And the last but not the least point is the dynamic resistance. Dynamic resistance. What is the dynamic resistance? This is another specification provided by the manufacturer, which helps to describe how vertical is the reverse characteristics. This is known as the Zener dynamic represent impedance, or RZ. What is RZ? Zener dynamic impedance. And it is defined as RZ equals to delta of VZ by delta of IZ. So by this we can define. Okay. RZ is equal to delta of VZ by delta of IZ. This impedance is generally evaluated in the region of specified test current I of ZT. Test current I of ZT, it is the test current, okay? And the reciprocals of the slope of reverse characteristics. Ideal RZ is 0 for perfectly vertical breakdown voltage. Okay. Clear, everybody? Everybody clear? कोई जवाब नहीं दे रहा है. So everybody understand? Hello? Is it audible?
Yes, sir.
Okay. So that is our Zener voltage or Zener current, and we have already discussed about the applications of a Zener diode. So these are all that about Zener diodes. I think this is enough for you for learning Zener diode. Now let us do some numericals problems. तो अभी तक जेनर डायट के बारे में किसी को अगर कोई मतलब कोई डाउट हो या कहीं पर भी क्लियरेंस चाहिए तो बता सकते हैं, ताकि हम लोग न्यूमेरिकल से पूर्व ये थोड़ा डिस्कस कर लें. So numericals, we are discussing on numericals. Okay. So nobody has told me anything. So I think there is no confusion about Zener diode and all the things. No problem. अगर कुछ प्रॉब्लम हो तो बता सकते हो. So no problem, I think nobody is responding. So we are going to start the next portion, that is numericals on Jenner diode. Okay. So we will perform 2 or 3 numericals on this Jenner diode, and after that the rest of the problems, please you have to do it at home. तो तुम लोग कुछ नहीं बोलो, तो हम लोग शुरू करते हैं हमारा एग्जाम्पल। 3 और 4 करेंगे क्योंकि जनरल डाइट से बहुत सारे क्वेश्चन आते हैं। A Jenner diode shunt regulator is shown in below figure. Determine number 1, the load voltage. Number 2, voltage drop across series resistance. Current through the diode. So let us draw the circuit diagram. Okay. So this is the RS. It is given that RS equals to 240 ohm. This is the PS, that is 30 volt. It is given in the circuit, okay? This is IS. This is IZ flowing this side. This is VZ. The value is given 12 volt. This is the load IL. This is the load resistance RL. That is also given 500 ohm. So this is the circuit diagram. Now we will do the solution for this. So what is given? A Zener diode shunt regulator is shown in the below figure. Determine the load voltage. Okay. Load voltage means VL, that is we have to determine. Voltage drop across the series resistors, that means across the RS, what is the voltage drop? Current to the diode. So what is the current to the diode? That means the value of IZ. Or the value of yes, current to the diode, that is IZ, but we have to also calculate the value of IS also for calculating that thing. Okay. सब सुन रहे हो कि नहीं सुन रहे हो?
Yes, sir. Yes, sir. Sorry, sir.
अच्छा अच्छा. तो यहाँ पर क्या दिया हुआ है? अगर इसको सॉल्यूशन करने के लिए हम लोग करें तो यहाँ पर क्या हुआ है? हम लोग लोड वोल्टेज जो है पहले जो दिया है, द लोड वोल्टेज हमको कैलकुलेट करना है. ओके, लोड वोल्टेज कैसे कैलकुलेट करेंगे? आप लोग जानते हैं लोड वोल्टेज इज इक्वल्स टू द जेनर वोल्टेज. So I
Yes,
will
sir.
write, so I can write here load voltage that is equals to VL, that can be equals to VZ, which is already given as 12 volt. So the number 2 point, voltage across the series resistance, that means this is series resistance, voltage drop across the series resistance. So we know Vs equals to IS RS plus VZ, or we can write Vs minus Vz equals to equals to IS into IS, or so as Vs equals to IS RS plus Vz, so you can write Vs minus Vz is equal to IS RS. So IS equals to Vs minus Vz by RS. That is equals to 30 minus 12 by 240. That is equals to 18 by 240. That is equals to 3 by 40. 6. I am multiplying the 6. 6. 3 6 are 18 and 6 40 240. So if I do it, it will come 0.075 angstrom. Sorry, ampere. So voltage drop across series resistance Rs is Vs equals to Is into Rs. That is equals to 0.075 into 240. That is 18 volt. I can write here Vs dashed because this Vs is not with this Vs. Now, current through the Zener diode is given by Is equals to Iz plus IL. So that can be written IL equals to VL by RL. That is 12 by 500. So that is equals to 0.024 ampere. That implies Iz equals to Is minus IL. So what is the value of Is? Is is equal to 0.075 minus 0.024. That gives you 0.051 ampere. So this is number 3. So that is the answer. So no problem, everybody. Any problem?
No, sir.
No, sir.
No, sir.
So we are going to do the next calculations. So another typical question. I'm just little bit late, I'm telling, because I have to go through different types of problems, and in that I'm choosing some important ones, means important types, not important ones I cannot tell, because everything is important. Okay. So let us write the question first. Today is basic. Okay. So let us take the problem number 2. For the below circuit, find the maximum and minimum values of Zener diode current. Okay. The circuit diagram is like this. This is the positive terminal. This is the negative terminal. This is the load IL current. This is the RL. This is VZ. This is IZ. This is 50 volt. This is RS. This is 5 kilo ohm. This is IS. This is plus. This is minus. This is Vs equals to 80 minus 120 volt. This is the result of 50 volt, 5 kilo ohm, RL equals to 10 kilo ohm. So this is given. Now what is the solution? So let us take a 5 minutes break so you can understand is this thing, and we will also take some 5 minutes break and then we will start. Okay, no problem, just 5 minutes. So let us back. What will be the solution? Sorry. From the circuit, we have minimum voltage drop across the series resistance RS is equals to Vs minus Vz, that is equals to 80 minus 50, that is equals to 30 volt. Why I write minimum? Because Vs is from 80 to 120. So I write minimum. So same maximum voltage drop across the series resistance RS is equals to Vs minus Vz equals to 120 minus 50 equal to 70 volts. So therefore, load current IL equals to VL by RL, that is equals to Vz by RL, that is equals to 50 volt by 10 kilo ohm, that is equals to 5 milliampere. So minimum current through RS IS mean equals to 30 volt by 5 kilo ohm, that is 6 milliampere. Therefore, minimum value of current through Zener diode that is equals to IZ mean, that is equals to IS mean minus IL minus IL, that is equals to 6 milliampere minus 5 milliampere, that is equals to 1 milliampere. So like this, again, maximum current through RS that is IS max equals to 70 volt by 5 kilo ohm, that is equals to 14 milliampere. So therefore, maximum value of current through the Zener diode IZ max equals to IS max minus I, that is equals to 14 milliampere minus 5 milliampere, that is equals to 9 milliampere. That is the answer. If anybody is not has not understand this, means anybody has not understand this problem. Please, I am giving you 2 minutes so that you can understand it. So everybody okay?
Yes, sir.
Okay. एक डिफिकल्ट प्रॉब्लम कर रहे हैं आज, और एक चीज तो आपका This is problem number 3. Determine the temperature coefficient of a 5-volt Zener diode at 25 degrees centigrade. If the nominal voltage drop, sorry, voltage drops to 4.8 volt at room temperature of 100 degrees centigrade. इसका solution. Change in Zener voltage. Change in Zener voltage. Delta Vz equals to 4.8 minus 5. That is equals to minus 0.2 volt. Next is change in temperature. That is also represented by delta T, and that is 100 minus 25 is equal to 75 degrees centigrade. So first case, you see the diode has a 5-volt temperature coefficient, but it is being dropped to 4.8. That's why I write 4.8 minus 5. And we have to calculate at 100 degrees centigrade, so 100 minus 25 degrees centigrade. So temperature coefficient of Zener diode that is represented by alpha z, that is equal to del of Vz by Vz into delta T into 100. So this is the formula. So that is minus 0.2 by 5 into 75 into 100. That is equals to minus 0.533%. This is as. Understand everybody? This formula you have to learn by heart this formula. Okay. Another problem. Temperature coefficient we have calculated. This one calculated. I want to calculate some power related terms. Is there a question on that power related? Zener power. Yes, this problem. You can try it. Number 4. Calculate the following in the given circuit. Circuit below. IS, IL, IZ, and PZ when number one condition RL equals to 2 kilo ohm and number two condition RL equals to 10 kilo ohm. And the circuit is so this is RS, this is equals to 2 kilo, this is 15 volt, this is the current flowing direction IS, this is the current flowing direction of IZ, this is positive, this is negative. We have given a value, we have got 10 volt the value is. This is the load resistance. This is the current flowing in the load resistance. This portion is also grounded. So this is the figure given. So what will be the solution? So let's do the solution. So we have Is equals to Vs minus Vz by Rs. That is equals to 15 minus 10 by 2 kilo ohm. That is 2.5 milliampere. Thus, Is does not depend on the value of RL. Now, load current IL equals to Vz by RL, that is equals to 10 volt by 2 kilo ohm, that is equals to 5 milliampere. That is when for RL equals to 2 kilo ohm, and this is equals to 10 volt by 10 kilo ohm, that is equals to 1 milliampere. That is for RL equals to 10 kilo ohm. Also, we know that Iz equals to Is minus IL, that is equals to 2.5 milliampere minus 1 milliampere. That is for RL equals to 10 kilo ohm. Again, Pz equals to Vz into Iz. That is equals to 10 into 1.5 into 10 to the power minus 3. That is equals to 15 milliwatt. That is also for RL equals to 10 kilo. So this is the answer. So I think these four numericals that we have done. So this is a different types. I have just concentrate on different types of numericals. Types are different, but the values can be changed. Different types of things can be introduced in these numericals. Understand? So you have to be very careful about that. You have to be practiced such a way that there can be a different types of numericals. Clear, everybody?
Yes, sir.
So these types of numericals are very important for your examination. I have given you just a view of just four types of different types so that I could cover all the types. But it is impossible for me to cover all the types because there are different types of. You can also, if you know it very well, you can also change the type of that problem. Okay, sometimes it is in equation, sometimes it is related to another value. So just you have changing the digit or changing the numeric values, and everything is changing. So you must practice it at home, because if you don't practice, then you cannot what? You cannot do it, or you cannot do it in the examination. So that is the end of the Zener diode. So hope this Zener diode thing will be understandable to everybody. And please, if you have any problem, you can take these documents from the teachment also. If you have any problem, you can write me on the teachment also. So please, thank you for joining this class, and have a good day. We will join again in Wednesday. Thank you. You can leave. किसी का कोई अगर डाउट है तो पूछ सकते हैं, अगर नहीं है तो लीव कर सकते हैं. Thank you for joining the class. Okay.